Hello students, welcome back. Today I am going to take your class on the topic Electrostatic Potential and Potential due to Electric Dipole. Students, as you know that the electric potential due to a point charge is given as V is equal to 1 upon 4 pi epsilon naught Q by R. And from this formula it is clear that V is inversely proportional to R. Yes? Clear? This is the diagram. Charge Q at distance potential will be this. This distance is equal if we consider a surface which is equidistant from the point charge, then the potential at the surface will be equal. Thus the electric potential due to a point charge is spherically symmetric, as it depends only on the distance and not on the direction. Clear? Students, electric potential is a scalar quantity. Okay, I want to tell you one thing more. This formula is electric potential due to a point charge. If there is question that what is the electric potential due to continuous charge distribution, as you know, there are three types of charge densities: linear charge density, surface charge density, volume charge density. And formula you also know. I am going to discuss only one case, that if it is linear charge density. You know, lambda is equal to Q by L. Lambda is equal to Q by L. Then Q is equal to L lambda. So you put the value of Q as L lambda. Then V is equal to 1 upon 4 pi epsilon naught L lambda upon R. The formula will be for the potential due to linear charge density. Yes? L, if it is circle, L will be what? 2 pi R. Clear? And similarly you can write for surface charge density, Q is equal to capital A into sigma. A is equal to 4 pi R square, like this. For this sphere, it will be 4 pi R square. And volume charge density, Q will be rho into V. Yes? Q is equal to rho into V. And V will be 4 by 3 pi R cube for the sphere of radius R. Yes? Okay students. If we want to find the electric potential due to group of charges, means this is point P and number of charges are placed there. What will be potential at this point due to these all the charges? Clear? It's a scalar quantity and therefore potential at point P will be a scalar sum, algebraic sum of the potential due to each charge. In this condition, charges are given as plus Q1 minus Q2 plus Q3 plus Q4 minus Q4. Minus means if we write the formula for the potential, we will put the charge with proper sign. And V1 is total potential will be V1 plus V2 due to this charge plus V3 due to this charge plus V4 plus V5. And what it is? Total potential V is equal to 1 upon 4 pi epsilon naught Q1 upon R1 plus 1 upon 4 pi epsilon naught minus Q2 upon R2 plus this plus 1 upon 4 pi epsilon naught minus Q5 by R5, where R1, R2, R3, R4 and R5 are the distance of the charges from Q1, Q2, Q3, Q4 and Q5 respectively. On taking common, 1 upon 4 pi epsilon naught as given here, V is equal to 1 upon 4 pi epsilon naught Q1 upon R1 minus Q2 upon R2 plus Q3 upon R3 plus Q4 upon R4 minus Q5 upon R5. Students, now I am going to discuss electric potential due to a dipole. For the dipole, there are two conditions. One is the axial position and other is the equatorial, that you all know. So first I'm going to discuss at an axial point on the dipole. And what is the axial point? That you know very well. I have already discussed it in the case of electric field. AB is the dipole, midpoint O, from point O at distance R there is point P, which is axial point at which we have to find the electric potential. Clear? The distance from plus Q charge of P is R minus A, and from minus Q charge it is R plus A. Any doubt? No? Okay. The potential at point P due to plus Q charge will be what? V1 is equal to 1 upon 4 pi epsilon naught Q upon R minus A. Equation number 1. Potential at P due to minus Q charge will be what? V2 is equal to 1 upon 4 pi epsilon naught minus Q upon R plus A. That is minus 1 upon 4 pi epsilon naught Q upon R plus A. Equation number 2. So what is the net potential at this point P due to this complete dipole? Potential at point P due to this complete dipole will be the sum of potential due to plus Q charge and due to minus Q charge. And therefore from equation 1 and 2, V is equal to V1 plus V2. That is 1 upon 4 pi epsilon naught Q upon R minus A. V2 is negative, therefore minus 1 upon 4 pi epsilon naught Q upon R plus A. Taking common Q upon 4 pi epsilon naught, we will get this one, and taking LCM R minus A and R plus A. The LCM of R minus A and R plus A is what? R square minus A square, and which gives Q upon 4 pi epsilon naught R plus A minus R plus A upon R square minus A square. Students, after solving that, R will be cancelled out, that you know from the previous sheet. Now V is equal to Q upon 4 pi epsilon naught 2A upon R square minus A square, and 2QA is what? P, and therefore V is equal to 1 upon 4 pi epsilon naught 2QA upon R square minus A square, that is 1 upon 4 pi epsilon naught P upon R square minus A square. Clear? And this is the formula for the potential due to a dipole in axial position. Like previous case, if A is very small as compared to R, on neglecting A, what we will get? This will be out. Yes, and we will get V is equal to 1 upon 4 pi epsilon naught P upon R Q. Clear? This is the formula for potential due to a dipole in axial position. Students, note it down that since potential is a scalar quantity, the formula for potential will be written with charge with proper sign. That is, for the negative sign, we will write minus Q, and for positive sign, we will write plus Q. Clear? Okay. The next condition is what? It is electric potential due to a dipole at an equatorial point on a dipole, which is given here. Yes? Like previous case of electric field, you know what is the equatorial position, what are the distances that are given here. This is dipole AB, this is midpoint. From this point at distance R there is point P. At this point, equatorial point, we have to find the potential. The distance of this point from plus Q charge is under root A square plus R square, and from minus Q charge is also R square plus A square. Yes? So now potential at point P at this point due to this plus Q charge will be what? V1 is equal to 1 upon 4 pi epsilon naught Q upon BP, and BP is under root R square plus A square. So V1 is equal to 1 upon 4 pi epsilon naught Q upon under root r square plus a square. Equation number 1. Yes. Potential at point P due to minus q charge will be what? This will be V2 is equal to minus 1 upon 4 pi epsilon naught q upon under root r square plus a square. Why minus? Because of this is negative charge. We will write when negative here, it will come here. Clear? So now, what is the total potential at point P due to this complete dipole? This will be the sum of potential due to plus q charge and minus q charge. Any doubt? No? So V is equal to V1 plus V2. V1 is from equation number 1 and V2 from equation number 2. It is clear from equation 1 and 2 that the magnitude of V1 and V2 both are same, and therefore on putting it here we will get V is equal to 0. Clear? So students, in equatorial position, potential due to dipole will always be 0. Clear? Any doubt? No? Okay. Students, previous two cases of axial and equatorial position were same as that in the case of electric field, and therefore it will be very easy to understand the topic. Clear? Now the next topic is electric potential at any general point due to a dipole. General point means neither axial nor equatorial. This is a dipole AB having charges plus q and minus q. Clear? This is midpoint, distance 2a. From midpoint at distance r, there is a point P. The line joining O and P is making angle theta with dipole moment. Yes? Clear? The line is making angle theta with the dipole moment. And we have to find the potential at point P due to this dipole AB. Students, since it is a scalar quantity, we will find potential at point P due to plus q charge and due to minus q charge. As shown in the figure, the distance AP is R1 and distance BP is R2. Yes, and distance OP is R. Clear? Yes. Now, potential at point P, this point, due to this plus q charge will be what? V1 is equal to 1 upon 4 pi epsilon naught q upon R2. From plus q charge distance is R2. Therefore, it is R2. Equation number 1. And potential at point P due to this minus q charge will be what? V2 is equal to minus 1 upon 4 pi epsilon naught q upon R1. This distance is R1. Yes? So what is the net potential? Students, it will be the sum of V1 and V2. So from equation 1 and 2, which are given here, we will put the value of V1 and V2 in this equation. V is equal to V1 plus V2. On putting the value and taking common q upon 4 pi epsilon naught. What we are getting here? In bracket, we are having 1 by R2 minus 1 by R1. This is R2, this is R1. 1 by R2 minus 1 by R1. Clear? So what is the V? V is equal to q upon 4 pi epsilon naught. The LCM of R1 R2 is R1 R2 and this will be R1 minus R2. Yes? And this is the formula for the potential at general point due to a dipole. But the problem is that if R1 and R2 both are not known, then how you will find this? You are given only the distance 2a and the distance of point from the midpoint of dipole. Then how you will find it? Students, if this point P is far away from the dipole, what I want to say, try to understand. If this point P is far away from this dipole, then line OP and AP will become almost parallel. Agree? If point P is far away from the dipole, then OP and AP will become almost parallel. Clear? And in this condition, this angle will be equal to this angle. That is, angle POB will be equal to angle PAB, which is written here. POB is equal to PAB. And since this is theta, this angle will also be theta. Any doubt? No? Students, from the previous figure, which is also here, in triangle ABC, I told you that this angle theta will be equal to this angle theta if the point is far away, right? So now you draw perpendicular on this line, and BC is perpendicular on AP. BC is perpendicular on AP, and therefore this will be equal to this, and therefore AC will be R1 minus R2 because of AP is what? R1. AP is R1 and BP is R2, and therefore AC will be what? R1 minus R2. Yes? And since these two angles are equal, in the condition when P is far away, cos theta is equal to base upon hypotenuse. So cos theta is equal to AC upon AB. AC is R1 minus R2. AB is 2A, which will give you R1 minus R2 is equal to 2A cos theta. Clear? R1 minus R2 is equal to 2A cos theta. And R1 into R2 will be equal to R square, R1 and R2. Clear? So approx these two, R1 minus R2 is equal to this, and R1 R2 is equal to R square. So putting these two value in previous equation, what is the equation? V is equal to Q upon 4 pi epsilon naught R1 minus R2 upon R1 R2. Put it here, this will be this equation, and 2QA is P. So this will be V is equal to 1 upon 4 pi epsilon naught P cos theta upon R square. And this is the formula for the potential at any general point. Clear? V is equal to 1 upon 4 pi epsilon naught P cos theta upon R square. Yes? This is the formula. We can write this equation in other forms as you multiply it by R and divide it by R. This will become 1 upon 4 pi epsilon naught P into R cos theta upon R square into R. Yes? Multiplying and dividing by R, we will get 1 upon 4 pi epsilon naught P into R into cos theta upon R cube. R square into R. This will be R cube. Yes? AB cos theta is what? A dot B. Vector A dot vector B is equal to AB cos theta. And therefore P into R into cos theta is equal to vector P dot vector R. So therefore V is equal to 1 upon 4 pi epsilon naught vector P dot vector R upon R cube. Yes? Clear? Or if you want, write it in the form of unit vector as given here. Unit vector R is equal to vector R upon R. Then this equation will become V is equal to 1 upon 4 pi epsilon naught vector P dot unit vector R upon R square. Clear? Okay. Students, from equation 4, if you write theta is equal to 0, theta 0 means the point is on the axis of dipole. That is the axial point. What it will be? Cos 0 means 1. Yani V is equal to 1 upon 4 pi epsilon naught P upon R square. It is given here. 1 upon 4 pi epsilon naught P cos 0 upon R square. That is 1 upon 4 pi epsilon naught P upon R square. And which I have already told you in that particular case. The condition 2, when theta is equal to 90 degree means this is the dipole and 90 degree. Yani equatorial point. It means if the point is equatorial point, then theta is equal to 90 degree. Put here 90. Cos 90 means 0 and V is equal to 0. Written here 1 upon 4 pi epsilon naught P cos 90 upon R square, and that is 0. And therefore, this is the general condition with the help of which you can find the formula for potential in axial and equatorial position by putting theta 0 and 90 respectively. Clear? Okay. Students, now I'm going to discuss the potential due to uniformly charged thin spherical shell. This is a spherical shell of radius capital R and it is uniformly charged with charge plus Q. Three conditions are there. Outside the shell, point A, at the surface of the shell, point B, and inside the shell, point C. Clear? Students, if we draw the line of force from these charges, you know, these lines will be perpendicular to the surface of a sphere. Yes, these all the lines from the surface will be perpendicular to the surface and outward. Yes, when we produce this line backward, they all will meet at the center of this shell. Clear? The electric lines of force from positive charge goes outward and perpendicular to the surface of the shell. When we produce these lines back, they meet at the point O, and it appears that these lines coming out from the shell are due to the charge Q present at point O. Yes? So we know that the charge is available or present at point O. It is supposed that this charge is uniformly distributed at the surface, but it is supposed that it is situated at point O. Then we know that potential due to a point charge at distance R is what? 1 upon 4 pi epsilon naught Q upon R. So if we want this potential at the point outside the shell, that is point A, then if the distance is small r, then potential will be V is equal to 1 upon 4 pi epsilon naught Q upon R. Clear? Second point, at the surface B point, at the surface of shell B point, the distance is capital R and therefore VB is equal to 1 upon 4 pi epsilon naught Q upon capital R. Yes? Students, now the last and important point, that inside the shell at point C. Students, in my next lecture, I will tell you one relation, that E is equal to minus dV by dr. Yes? Electric field intensity is equal to minus dV by dr, which is the termed as potential gradient. That I will tell you in my next lecture. And you also know that the electric field inside the spherical shell is what? 0. E inside the shell is 0. Yes? So therefore dV upon dr is equal to 0, and which gives V is equal to constant. Yes? If E is equal to dV by dr with negative sign, and E inside the shell is 0, and therefore dV by dr is equal to 0, that is V is equal to constant, and hence inside the spherical shell at every point potential will be same as at the surface, that is Vc is equal to Vb is equal to 1 upon 4 pi epsilon naught Q upon R. Clear? Yes? Now I am going to plot the graph between V and R. This is shown here, V and R. On the x-axis there is R, and on y-axis this is V, and this is the sphere of radius capital R. Yes? As you know, The potential inside the shell at every point is the same, and therefore from 0 to r, radius of the shell, it is maximum. It is maximum. And after the surface, it is inversely proportional to the distance VA proportional to 1 by r, and therefore it decreases as shown here. The graph plotted between V and R is like this, and this is different from the graph plotted between capital E and R. In the case of E and R, the graph was not like this. It was from here then down. Since inside the shell potential was, electric field intensity was 0. So from this point to this point it was 0, then maximum, and now it decreases. Clear, students? Any problem? No? Thank you. Now I will explain one numerical and then two questions for your practice. Students, this is a question for the potential, and which says that the two charges 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb are separated by distance 0.15 meter. At what point on the line joining these two charges electric potential will be 0? Students, we want electric potential 0, and since electric potential is a scalar quantity, and therefore take a point on the line joining two charges. I am taking this point P. This distance is 0.15, and therefore this distance will be x. Means the distance of point P from Q1 charge is x, and therefore distance of point P from Q2 charge will be what? 0.15 minus x. Clear? So now we will find potential at this point P due to this Q1 charge and due to this Q2 charge. These potentials will be V1 and V2. Here P is point taken on the line. The V1, that is the potential at P due to plus Q charge, that it will be 1 upon 4 pi epsilon Q1 upon x. This is the distance. On putting the value, what we will get here. Clear? And due to minus Q charge, what will be? V2 is equal to 1 upon 4 pi epsilon naught minus Q2 upon 0.15 minus x. Yes, this is Q1 upon x, and this will be minus Q2 upon 0.15 minus x. Now, the potential at point P due to the dipole will be 0 as given in the question. It is 0. So, V1 plus V2 is equal to 0. Put the value of V1 and V2. Put the value of Q1 and Q2. It is solved here. We will get the value, what? 9 centimeter. Yes, you solve it. The calculation is given here. You can see it. X is equal to 9 centimeter, and therefore at distance of 9 centimeter from Q1 charge, potential will be 0. Thank you. Students, this is my advice to you all, that prepare the notes of all the topics given by me or any other teacher. The topics taken by me are most important. So please prepare your notes, that I will see when you will be back to your college. Thank you.